Alright. This is the test rig set up for drive test, drivetrain. So let me see if I can get everything in frame here. Got it latched up there. I have a controller and power converter there. Battery pack here running 36. Turning my converter to 12. Running the armature on that connection. And then my 3-phase on here from the controller. This is the rear wheel. It is still got some problems. See if I can get it. There is an aluminum bushing there. That aluminum bushing is actually causing some squeaking. Not sure if I can make a noise here. Yeah, there you go. Drivetrain on this side. Steel bushing on that side, the spacer. So that one doesn't seem to be making noise, but regardless, the entire axle is going to have to be pulled and lubed again before final assembly. The bearings have been lubricated, white lithium on these ones. And here's the connection for the sprocket. That is a double D bore 11-tooth sprocket for regular bike chain, 1/2 by 1/8, running a regular pedal sprocket from a BMX bike on that side. So going 11 to 36. So it is a 3-to-1 almost gear reduction. So estimated RPM on this motor is approximately 3,000 RPM. It varies from alternator to alternator, so my average that I've found for most alternators is about 3,000. This alternator specifically is off of Ford. I believe it's off a F-150. I don't remember which motor. Like I said, I got my 2-phase here for the armature. That's soldered and crimped both to the brush connections attached to the inside of the collars for the armature. My 3-phase here is literally directly attached to the 3 coils that come up through the side. They have a plastic housing that easily comes off. And it's connected right to those, soldered directly on with a metal sleeve over top of it. So it's nice and secure, no vibration's going to rip it off. This is the first drive test. This is going to be, while it is securely zip tied to a heavy metal chair and clamped to the bench. This is the first drive test that tests torque. I just did a short test before this to make sure it actually does turn, and it does. So I gave it a little bit of gas, and I'm going to have to say that the about 30, I think it was 34 to 35 mile per hour estimate I saw through the online calculator is probably going to be pretty accurate. It seems like it deals with load pretty well until it's basically at a dead lock. But even then you let off and it just goes again. So battery pack, as far as I know, is just above nominal, so it's probably about 38, 39 volts instead of the full 42. It's already on, so I'm going to give this a go. It's been on this entire time. I've been waiting to see if I see any smoke or if I see, whoops. I have to watch my connections here. I'm not getting any heat off the converter, so let me see if this thing is still on. It is. Alright, so this is going to be slow. It's probably going to squeak a bunch, so ready, here we go. Oops. Oh, it looks like my connection for the connection for the converter's off. There we go, okay. So I need a chain tensioner on that, obviously. It's turning pretty fine at low speed. That's just the sag in the chain that's doing that. I'm going to give it one good go here just to show you a test. It shakes like crazy, this chair and all that. Once this is grounded, I have a feeling that won't be an issue anymore. and a coast to stop. So that was about half throttle. Let me see if I can get it going on full throttle for a moment. It threw the chain. So yeah, that is exactly why the chain tensioner is necessary. I mean, that's what you can expect out of the motor at full go. It's going to be torquey as all hell. I think the problem with it is just the chain tensioning. Now I have tensioners here on the side. I'm not sure if these are going to be a permanent addition because these here, they have been giving me problems with, like, they're I've been kind of worried about it. This is a very heavy tire, and looking at how this is holding it back, when you look at its chain tension, it's putting a lot of force on just this little bolt. That little bolt there is the only thing holding the entire rear axle backwards. So what I'm saying is that if the torque of this motor running 20 amps on the armature, which is like ridiculous, has enough torque to snap those two bolts, that one or that one on the side, or even one of them at a time, the entire rear end goes out in one go. So I think the best bet is to, hold on a second, I just thought about something. Let me pull the power line off there. That'll shut down the controller. My best bet is to attach a chain tensioner here to this rod in line with it and give it some chain tension, some medium to light chain tension, nothing like too extreme, because I don't want to run the risk of binding these bearings and ruining them, like prematurely wearing these out or throwing the armature to one side or the other. So I think that is going to conclude my first test here of the motor setup. I think this is going to run fine. This thing was hauling a fair amount of power. Like I said, 20 amps on the armature, and it has 35, I believe, available to the motor on 3-phase. And from what I can tell with these motors, the intensity that these motors can take, since their coils they're wound so tightly on their coils, and with such thick gauge wire, amps are not really a problem with this one. I mean, these are designed well over 120 amps. The problem comes with when you look at how many amps you're going to run on the armature itself in the middle, because that is not normally designated to, it's meant to be running an output, not an input. So I have a feeling that since we are using this kind of setup, I'm going to have to, I probably am going to reduce the amount of amps on the armature by just running all the other 12-volt accessories, like a standard taillight headlight mandatory on the bike at all times. Anytime you start the bike up, it is going to run its 12-volt accessories like the headlight and taillight and brake lights. Brake lights are run through the controller, but maybe just the headlights and taillights. But that should cut away a few amps away from this armature. Now, what I was saying is I think the armature, the torque of the motor is dependent on how many amps you run through the armature, because it really depends on how hard it's going to shift away from one polarity to the next in its 3-phase configuration. Now, this is not set up in Delta. This is set up in a regular 3-phase. There are alternator motors out there that run a Delta configuration, which has the 3 poles in different spots and has them connected between each other as well, and they don't come to the middle. They just go to each other, and that's how they run their 3-phase. Those are known to be way torqueier, which is a great thing, but considering my purpose is a good combination of torque and speed, I mean, I'm not a light guy, but that's mostly why I'm having this set up as a little in-town bike. I have a feeling that is going to come into play uh, when it comes down to its final gearing. So as it is now, the speed is incredible. I definitely think I'm going to hit that 35 mark that I found on the racing calculator. Uh, but torque is my big thing. I did hold this tire still on the first test and try to turn it, and it's well, it takes off pretty. Once you get to a point, it'll grab hard and take off on you. But you have to kind of hold it for there's a momentary there's a moment in between where you can tell it's just trying to figure out like, well, how many amps should I use? And then the controller finally kicks in enough amps to overcome the 20 on the armature, and it really does launch that tire. So definitely something that if I got used to, I would hopefully just try to do a light kickoff every time I took off, just because of how it'd be a lot easier on the motor in the long run. But I think my biggest issues right now are going to end up being getting a chain tensioner that fits this. I can just weld one on if I need to, or I can go to, and then also I have to disassemble this rear axle, and I'm going to have to lube every little bit of it. I think what might be going on is that is supposed to be a bearing on the outside end, and I have a feeling that it is not. If it's not, I do think I might have a 12 mil bearing, as that's what that axle size is, 12 mil. I think I have a 12 mil bearing somewhere that will actually fit inside there and should be able to give me a little bit of resistance against that. And then I can just go with a little spacer there, possibly even a couple washers, and it'd be just fine. Or I could, possibly take that long one out of this end. But it looks like I might have to trim those bolts to do that. Alright, that's the update video, first test. So in case you can't see the configuration of how this is going to work yet, I have my rear tire and motor all as one drive assembly here, and this spot here in the vise. There will be holes drilled in the center here, and they will have a bolt that runs through the whole length of it, or threaded rod. As this is 6 inches long here, I don't think I'm going to find a bolt very easily that fits it. And I will be running most likely a tube here between it that has either bushings or bearings in the middle. I think I'm just going to go with, since it's not going to be going up and down very much, I think I'm going to err on the side of caution and get just some steel spacers inside of a tube, have them plug welded in the ends, pop a washer on the end of each end, and it should be good to go, no problems. Please excuse my sloppy welding job. I was in a hurry to get this thing mounted. I really wanted to check out how this is going to work before I continue with this project anymore. If I get time later, I might fix this. Okay, that is the full test. I have a quick drawing I should show you that this is kind of the idea here. So I have the tire has actually gone from assuming what was going to be the 26 inch down to a 20 inch to kind of more match the 17 inch size of the rear. And of course with that comes a shorter body overall there. I have the same front forks there. I have those right there, ready to go. And this upper section of frame is already completed as well, with the hangers for the battery pack. It has steel bands that go from there to there. This piece of steel down here, I'm considering just going all the way down and then in. Right here is going to be actually, instead of just a piece of tube going from there to there, I am going to have like a rectangular section like floorboards here in some kind of perforated steel or some kind of other expanded metal maybe there for me to just rest my feet on, because honestly there's going to be no need for anything intricate on this. No pedals, no anything like that. It's going to be exactly be an electric moped in every way. Got a spot for my converter and a controller. Not sure if that's going to end up right now because I don't know if this is going to be a single piece or two pieces going vertically between the upper and lower sections. But all I know is this is going to be my connection here. This is probably going to be where that tube is, and it's probably going to be welded on right here in the exact corner, going up and then left going that way. Alright, so that is the last bit of this for right now until I have a chain tensioner on this, and then I can have the entire thing retested a couple more times, and hopefully at that point I will have this figured out and the uprights and the floorboard section made. Therefore I can just take it all out and weld it up at once. Alright, I'll check in with you guys later. Thanks.